Please give a very warm welcome to Kristen Heat1.
Morning everybody, my name's Chris, I'm a fire engineer. And I want to use today my knowledge of heat transfer to show you how I can hold a candle up against a balloon and it won't burst. Now, just so we're all clear of what usually happens when you hold the candle up against a balloon, it's something like this. And my camera goes out. So, heat transfer. Why did this balloon pop? Balloons are made of rubber, or in this case, latex, which is a really poor conductor of heat. So what happens, and the air inside it is also a really poor conductor of heat. So all of the heat from the candle gets concentrated on one tiny little part of the balloon, which gets weak, and then the balloon bursts. So what we want to do is work out how we can transfer some of that heat elsewhere, so it's not all concentrated on one little spot. There are three ways that heat can be moved. You have radiation, which is what you feel if you hold your hand adjacent to, say, a candle flame. So that's nice. There we go. So if I hold my hand here to the side of it, I can feel the heat from the flame. That's radiation. It's the same way we feel heat from the sun. The second mode of heat transfer is conduction. Now I'm sure all of you have a saucepan at home, or know someone who does, have a metal candle. And when you go to grab the handle, it's been on the stove for a little while, it's hot. That's because the heat from the stove has heated up the base of the saucepan and then spread out through the rest of the saucepan to make the handle hot as well. And that's conduction. And our third method of heat transfer is convection. And that happens in fluids, so liquids or gases, where the heat is applied at a point creates currents in the liquid and that, or fluid, and that transfers the heat, mixing it around the fluid. And a good example of that might be a lava lamp. You'll see one of those with the heat at the base, and it causes the liquids inside to churn up, and that spreads the heat out throughout the lamp. So I'm going to take this balloon. This balloon's a little bit different to my first balloon because I put a little bit of water inside it. There's not very much, it's just sort of maybe that far. What's going to happen is the heat from the candle is going to be conducted through the latex. Although it's a poor conductor of heat, it's very, very thin, so the heat should pass through it with no worries, and into the water at the bottom of the balloon. The water in the balloon will start mixing those warm currents and take the heat away from the latex, so it doesn't heat up. So if we try it now.
Huge round of applause.